Good morning, everyone. Hope all is well. Hope everyone's doing all right. We have people still trying to connect, so let's give them a chance to do so before we get started. All right, so looks like everybody's in here. So we can go ahead and get started. I sent out an email last night about Math Lab, so make sure you check that out. If you have not seen it yet, give you instructions on how to get connected. Everything should be fine. Had people in my 8 o'clock that was able to get in. So if you're having issues or having trouble getting in, make sure you let me know. But you should be able to get in okay by following those instructions that I gave, that I sent out last night. All right. Always remember, if you're not seeing my emails, check Blackboard Announcements. All of your emails will be archived in your Blackboard Announcements. So if you think you haven't gotten anything or haven't been seeing any emails, had somebody earlier said that they haven't been getting any emails at all. If you are in Blackboard and you're in our shell, then your Blackboard Announcements will have all of those emails. All right. So hopefully you saw the email from the NSU sent out about inclement weather. You know, that's why we're doing this right now. Classes are supposed to shut down at 12, but just in case somebody is traveling and, you know, may feel that being in class is imperative and all the stuff like that. Just want to make it clear across the whole classroom. Just make it just one Zoom and just go from there like that. Just erring on the side of caution. So that's why we're doing this. Making sure everybody's straight. Okay, so we're starting at 6.1 today, algebraic expressions and formulas. And always, since most of you do not have your cameras up, if you are copying when I scroll up, all you have to do is either type in the chat, or if you have any questions, you can type in the chat or unmute. Either way is fine. But I won't know unless you let me know. So if I scroll up too fast or do anything and you need me to slow down or to repeat something or whatever the case may be, let me know and we can go from there. But an algebraic expression is just a combination of variables and numbers using operations of addition, subtraction, multiplication, etc. You know, exponents and so on. So just quick examples of that: x plus 2, 3y minus 5, a squared plus 7b minus 8c are all examples of algebraic expressions. Scrolling up. So everybody done with the purple? All right. Let's see. All right, cool. Thank you. Thank you. So next thing's order of operations. So PEMDAS is one way to remember your order of operations. Please excuse my dear Aunt Sally or Shantae or, you know, whatever your aunt name is. You have P for parentheses, but for us it'll be any grouping symbol. So parentheses, bracket, or braces. E for exponents, M multiplication, D division, A addition, S subtraction. So notice that there are 4 levels, there are 4 tiers of operations. Even though we have 6 letters, there are only 4 levels of operations. Parentheses and group of symbols get your attention first, then exponents. Third is multiplication and division. So neither one of those take precedent over the other. Multiplication and division are on the same level, and you do them from left to right. So you have to be careful with that. Multiplication does not take precedent over division. You do them from left to right as you see them in your equation. And the same thing goes for addition and subtraction. Addition and subtraction, once again, are on the same level, and you do them from left to right as well. All right, scrolling up. Okay, it's not for me. Everybody good with this? All right, so next exercise is to actually use order of operations. They tell us to evaluate, they give us an algebraic expression, and tell us to plug in a variable, plug in a number for the variable that you have from your order of operations. So the first one, 7 plus 5 times x minus 4 cubed, and they want us to evaluate for when x is equal to 6. So we're just going to plug in 6 where we see x. All right, so instead of erasing, I'll just walk you through it. Here we have 7 plus 5 times x times 6 minus 4 cubed. So the first thing you want to do is the 6 minus 4. So that's how we get 2 right here. So that's 7 plus 5 times 2 cubed. So next you're going to do the 2 cubed. 2 cubed is 2 times 2 times 2. And that'll give us 8. So now we're here, 7 plus 5 times 8. So according to order of operations, multiplication comes before the addition. So 5 times 8 is 40. Then 7 plus 40 is 47. Any questions on that first one? All right, that's what I said. Thank you, thank you. Try to make sure everybody have an opportunity to copy. Cool, appreciate it. Anybody still copying and I scroll up, let me know. Okay, so the next one, next one, x squared plus 5x minus 3. They want to evaluate for when x is equal to -6. So we're going to plug in -6 in each spot that we see x. So -6 squared plus 5 times -6 minus 3. So the first thing that should get our attention is the square. So -6 times -6 is positive 36. All right, so now we have 36 plus 5 times -6 minus 3. So we do the multiplication of 5 times -6. That'll be -30. Now this parentheses right here around the -30 is just separating the minus sign, the negative sign from the plus sign. So there's nothing in the parentheses to do. It's just holding that negative 30 there. So we have 36 plus negative 30. That will be the next move, which will give us 6. And then 6 minus 3 is 3. All right, everybody good? Got one more like this anyway. Wanted to use one that had X and Y involved, or more than one variable. So we have 2x squared plus 5xy minus y. So we have x and y that was plugging in for. All right, so right here, whoa, that's substitution. So that gives us -2 times 4 squared plus 5 times 4 times -2 minus -2 cubed. All right, so next thing we need to do, or the first thing we should do, are your exponents. All right, so 4 squared to give us 16. -2 cubed. That's -2 times -2 times -2, which is -8. So now we have -2 times 16 plus 5 times 4 times -2 minus -8. So -2 times 16 would be the next thing we do, which would be -32. Then we have 5 times 4 times -2. So 5 times 4 is 20. 20 times -2 would be -40. And then we have this negative to a negative. We can go ahead and turn that positive. Negative to a negative turns positive. So we have -32 plus -40 plus 8, excuse me. -32 and -40 is -72. Then -72 plus 8 is -64. Any problems? All right. Next thing, like terms versus unlike terms. Like terms will be terms that have the same variables, same amount of variables, same exponent on your variables. These are terms that we can add and subtract from each other without any issues. So 5x and 3x are like terms, 10x squared, 12x squared, 18xy, 105xy, and even numbers without variables at all, the regular numbers that we normally deal with, 7 and negative 25 are examples of that, and they are considered like terms. If anything changed in your variables or your exponents with your variables, they are not like, and you cannot add them or subtract them from each other. So 5x and 3 are unlike terms. You will not be able to add them or subtract them from each other. 10x squared, 12x, 18xy, 105x squared y. In both cases, both of those last cases, one has a power of 2, the other one doesn't. So you cannot add them or subtract them from each other. All right. So the next thing is just different variations of similar terms, just emphasizing what we can and cannot add to each other or subtract from each other. So here we have 5x plus 3x will come together and give us 8x. You would just add the numbers in front of the variables. 5x plus 3, you cannot add together. So that's already an expression that's in lowest terms. 5x plus 3y, one has an x, one has a y, so you cannot add those together, already in lowest terms. 5x squared plus 3x squared, that will be 8x squared. Notice we do not alter the variable, the exponent on your variable. So that stays as x squared, and all you do is add 5 and 3 together. And then in the last one, 5x squared plus 3x, the exponents on your variables are different. So it's already in lowest terms, you cannot add them together. All right. So let's take the next exercise, same type of thing. They want us to simplify, but they're going to add and have actual expressions for you guys to simplify further. So the first one, 5 times the quantity of 3x minus 7 minus 6x. So normally when we talk about order of operations, you would do what's inside of the parentheses. There's nothing that we can do inside of here because we cannot combine 3x and 7 together. So we'll go ahead and distribute 5. 5 times 3x would be 15x. 5 times negative 7 would be negative 35 or minus 35. And then you still have minus 6x on the outside. Then from there, combine your like terms. 15x minus 6x will be 9x. And just bring down your minus 35. Any questions? Any questions? All right. Next one, we have 6 times the quantity of 2x squared plus 4x plus 10 times the quantity of 4x squared plus 3x. And we want to simplify. So distribute 6, that'll be 12x squared plus 24x. Distribute 10, that'll be 40x squared plus 30x. Then we combine our like terms. 12x squared plus 40x squared would be 52x squared. And then 24x plus 30x, 54x. All right. Last one out of this section. Any questions before we get to it? Everybody good? All right, so we have 8x plus 2 times the quantity of 5 minus x minus 3. So whenever dealing with grouping symbols and we want to simplify an expression or evaluate an expression, we always work our way inside out when it comes to our grouping symbols. You always want to take care of your innermost grouping symbol first. So you see inside of here, inside of the brackets, we have parentheses. So we want to get rid of that parentheses. First thing we'll do is distribute the negative. So notice we do not distribute the 5. We distribute that what is right up against the parentheses. You cannot distribute the 5 unless it's right up against the parentheses. So be careful with that. A lot of people, make that mistake. They want to distribute -5 or distribute 5 or something like that. So you don't distribute anything into a parentheses or into any grouping symbol unless it's right up against that grouping symbol. So we see this minus sign is right up against the parentheses. So we're going to distribute the minus sign. Doing that will change the sign of each term that's in the parentheses. So that'll take us here. That'll give us 8x plus 2 times 5 minus x plus 3. Now that we got rid of the parentheses that's inside of the brackets, we can still simplify inside of the bracket, combining your like terms of 5 and 3, and that'll be 8. So it'll be 8 minus x. Now, since we've simplified as much as possible inside of our bracket, we can go ahead and distribute the 2. That's, once again, is right up against the bracket, so we can do so. So distribute the 2. That'll be 8x plus 16 minus 2x. And now we can finally combine the last of our like terms, 8x minus 2x. That'll be 6x plus 16. Any problems, any problems? All right. So that's it for 6-1. Wanted to do a few problems out of 6-2. And we won't finish it, but at least get us started in 6-2, and then we'll call it a day. Questions before we get to 6-2? Is everybody good? All right. All right. So 6-2. Now we're getting into solving, getting into equations. Last section we had expressions. Here we're getting into equations. So linear equations are one variable. An equation is just a statement that two algebraic expressions are equal. X plus 5 is equal to 7. So x plus 5 equals 7 is a simple example of an equation. When it comes to these equations, we're going to be solving for them. What we solve for will be our solutions. The solution is the value or values that will make an equation true. So in this case, in this example, 2 would be the solution for x plus 5 equals 7. So basically, you're answering the question, when is x plus 5 equal to 7? And that is when x is equal to 2. All right. Any problems? Any problems? All right. So to solve, we will use what I call opposite operations. The operations that undo what the other one does. Addition and subtraction are opposite operations, multiplication and division. Opposite operations, they undo what the other one does. All right. Also, another foundational statement when it comes to solving, whatever you do to one side of the equal sign, you have to do to the other. All right, can I scroll up? All right, so your equal sign separates right side and left side of your equation. And you are looking to solve for your variable. You're looking to get your variable by itself on one side of your equation. So if you're over here and you see x plus 5, you know that 5 is being added to x. You need to undo the addition of 5. So what you're going to do is subtract 5. But like I just mentioned, whatever you do to one side of your equal sign, you want to do to the other. So if my equation is separated by the equal sign, if I subtract 5 on the left side, I need to subtract 5 on the right side. So the 5's cancel on the left, 7 minus 5 is 2 on the right. And so that is the foundation of solving equations. Your equation is separated, right side, left side of your equal sign. Your goal is to get x by itself. And so whatever you do to one side of your equation, you have to do to the other, using these opposite operations to undo what's being done to x so that you can get x by itself. So that's your goal, to get x alone or by itself on one side of the equation. All right, so let's do a few more of these one operation equations. If I do this. All right, so let's do a few more of these one operation equations. So y minus 10 equal to 30. I want to solve for y. So, but I have y minus 10. So what I need to do is add 10 to both sides of the equation. 10 cancels on the left, leave me with just y. And on the right, 30 plus 10 is 40. All right, so that's why we have y equal to 40. In the middle, we have 5a equal to 13. 5a is 5 times a. So that's why I was emphasizing here in the green box, that's multiplication. So 5, so we want to divide both sides by 5. 5 over 5 is 1. So we say loosely that it cancels out 5 divided by 5. And then that leaves you with 13 over 5 as your answer. Now, you do not have to convert that to a decimal or a mixed number. Down here in the green, I was emphasizing what you are expected to do if you can. 13 over 5, you cannot do anything with that. But let's say if I had 4 over 6, you are expected to reduce your fractions. They're not going to ask you to do it. They expect you to do it. And so, 4 is 2 times 2, 6 is 2 times 3. So your 2's can cancel and leave you with 2 over 3 as your most simplified representation of that fraction. So that is something that you are expected to do. Converting it to a decimal or converting it to a mixed number is not something that you are expected to do, and you don't have to do that. So just making sure we know the difference on that. So before we look at this last one over here, questions on anything I've said up to this point, make sure we're good. All right, scrolling up. Oh, no, not scrolling up, got to do this last one. So we have x divided by 9 on this last one to the right. So we need to multiply both sides by 9. So these 9's can cancel, leave me with just x on the left. Then on the right, 11 times 9 is 99. And don't forget, you can always check, I don't think I mentioned it earlier, but you can always check your solutions by plugging them back into the equation and see if it works out. So, going here, 40 minus 10 is 30. Same thing, we're plugging in 13 over 5 times 5 would just be 13, and then 99 divided by 9 would be 11. So you can always go back and check your solutions by plugging them back into your original equation. All right. Questions before we do a few more of solving? All right, good. Okay, now we're going to add a few more steps to it. Not a question, our equation is 2x plus 3 equal to 17. So be careful here. Directions are to solve. Remember last section, our directions were to simplify. You cannot solve if you don't have an equal sign. Those expressions that we had last section, all we had were expressions and terms. So all we could do was combine them. We couldn't actually solve because there was no equal sign. Here we have an actual equation. And so that's why we're able to solve. Okay. So now here, we're trying to solve for x. We want to get x by itself. Now we have 2 times x plus 3. So we could actually move the 2 first or the 3 first. Now, if we wanted, we could move the 2 by dividing both sides by 2. But now we're going to create a fraction or create fractions when we don't necessarily have to. So that's not the most efficient move to make. The best move and the most efficient move to make is to subtract that 3 first. So that will always be the best move to make. Move the term that's not connected to x first, and then look to divide or whatever you need to do. Remove the number that's attached to your variable. So we subtract 3 from both sides. That'll then give us 2x equal to 14. 3's cancel on the left, and 17 minus 3 is 14 on the right. And then we can finish it all by dividing by 2. 2's cancel, leave me with just x. 14 divided by 2 is 7. And that'll be our answer. All right. Very good. Before we go to the next one. All right, so here we have 2 times x minus 4 minus 5x equal to -5. So notice we have 2 different terms that have x involved. So we need access to both terms that have x involved. And right now we do not because we have parentheses here. So we're going to distribute 2 so that we can get rid of the parentheses and have access to all of our terms. I say free access to all of our terms. So 2 times x is 2x. 2 times 4 is 8. Now we can combine our like terms. We have 2x and -5x. That'll be -3x. So we have -3x minus 8 equal to -5. Now we're in a similar position that we were in the last problem. We have something being multiplied to x, then we have something being added or subtracted from it. So we want to go ahead and move that 8 first. That would be the most efficient move. So we're going to add 8 to both sides. That will give me -3x on the left. And then -5 plus 8 is +3. And then to finish it off, oh, my eraser's still on. To finish it off, divide both sides by -3. X will be equal to -1. All right. Questions on anything? Any questions? Any questions?
How did you get the negative 3x again?
All right, we have 2x and negative 5x.
Oh, okay. Okay.
Yep. Mhm. So we add those together and they gave us negative 3x.
Okay. Thank you.
Mhm. Anything else? Anybody else? Everybody good? Make sure we have clarity. Yep. That's where we stopped at in my last class. So that's a good place to stop. Um, Next class, we'll do a few more. We're still in 6-2. So we'll do more solving and then go from there. If we have enough time to jump into 6-3, we will. If not, it's no big deal. But main thing was to go ahead and get rolling and making sure you guys have something to, ponder and think about going into the weekend. Main thing now is to get access to Math Lab. Make sure you can get into Math Lab. Remember, nothing is due by next class. But what you do want to make sure you do is that you get started. Even though nothing is due, you don't want to wait and have the stuff just lingering because you are responsible for whatever we cover. So you have assignments already posted. Really, all of your homeworks are posted already. So really, you can move ahead as you like. But the main thing is to get in the Math Lab, make sure you don't have any issues doing so, and make sure you go ahead and get started. Our due dates, I think I mentioned it today. I may not have mentioned it today. I know I mentioned in my last class already today, but we talked about due dates. There are only 3 major due dates. That's your 5th week grading period, not grading period, but 5th week assessments, 10th week, and then the final day of submission. Right now, they're all set for that final day of submission. But as we get closer to 5th week, we will set a date for whatever we talked about to that point. See, right now, I don't know how fast we're going to move, how slow we're going to move. So I don't know what sections we will for completely that we will be held responsible for 5th week. I'm assuming chapter 6 and 7. Now, as far as 8 and 9, how much of that? Then we'll talk about that when we get closer to it. So probably 6, 7, 8, and 9. Well, I know it's be on Blackboard. I will convert this video right here to a YouTube link and then shoot that link to you, and then you have access to it, and you'll be able to pause or rewind and do what you would like with it. All right, somewhat. Yep, so that wasn't a private, chat, but somebody said in the chat, asking about are these notes accessible through Blackboard. So, yep, going to convert this to a video. One of the lectures I have three 103, so one of them I'll convert to a video, whichever one sounds the best. Convert to a video and then shoot that to you guys. All of them talking about the same thing. So, all right. Anything else? Anybody else?
Yes, I had missed first class on Tuesday.
Mhm.
Will I be able to go back to a video or something to get notes?
We didn't do anything. All we did was talk about class happenings. So all you have to do is check out those emails that I sent, because all we did was just make sure no one had any questions about anything that I sent out. So all you have to do is look at those emails that I sent out. They're all of them archived in your Blackboard announcements if you didn't necessarily get them in email. I'll always archive your emails and Blackboard announcements, class emails and Blackboard announcements. So go check those out. See if you have any questions on anything, and then shoot me an email, or if you want to meet in Zoom and talk, or whatever the case may be, we can do that.
Okay, thank you.
Yep, no problem. Anything else? Anybody else? Everybody good? Everybody straight? All right, so just re-emphasizing, going back to what your classmate just mentioned, this is our first day of actual lecture. So if you missed the first day, you didn't miss anything. It was just, making sure everybody's clear on what we're doing for the semester. All right. So
Okay, quick question.
okay, yeah, what you got?
Sorry.
Are you fine?
So I actually went to the class today and I was just sitting there waiting until I got to my email. How
Mhm.
often will we be on virtual?
Normally is we face to face, and you can do virtual as an option. I'm going to Zoom every day as well, and I'm going to teach
Be in
face to
class.
face, be in class.
Okay.
So the only thing that did us, a little different this time is because of the announcement in Norfolk State sent out about inclement weather. So I was trying to be, cognizant of that. So most definitely pay attention to your emails, because I kind of have to communicate that way. just because I allowed, because see, this is what happened. You know, you weren't there on the first day, but the reason why I went this way and went this route is because right before I went to send out introduction emails, because I was trying to figure out what I was going to do, somebody hit me with, I'm going to be quarantined for such and such days because I got COVID. You know what I'm saying? So I was like, we already starting
Right.
off with that. So I'm like, okay, I
Right.
didn't want people to feel like they had to come to class and all that stuff like that. And
Right.
so I'm not even checking attendance when you come in face to face. I'm not checking attendance through Zoom. I'm checking your attendance through your math lab activity.
Okay.
So I'm trying to keep it clean across the board so nobody feel like, man, he see me here or he don't see me there or whatever. So your
Right.
math lab activity is how I would confirm your attendance. So even if you don't complete an assignment, make sure you at least go into math lab and hit save on a homework, because you get unlimited amount of tries, so it's not going to mess up anything. But hit save, and that will give you a timestamp for your activity that week, and you're good to go. So yeah, that's how I'll be doing attendance. And yeah, so it will always be the option of Zoom. It'll always be the option of face to face, unless you see an email from me. So always check your emails. Somebody just mentioned in the chat that some of my emails go to junk mail. So they said check your junk mail. So I'm probably, well, I would say, I
Okay.
said, yeah, I'm going to send an email, because even if you're not seeing it in your email, you see it in Blackboard announcements. I'll send an email. Thank you for that. I appreciate it, to let people know that some of the emails do go to your junk mail. So be careful. That's crazy that it would do that, since all of
Mhm.
this is supposed to be NSU connected. But so I'll send something out on that as well. So yeah, y'all, you guys are supposed to be getting emails from me. If you don't see anything, and I did warn the class about this first day, if you don't see anything from me and you're concerned, always go back to your Blackboard announcements, because any emails I sent to the class will be in your Blackboard announcements.
Okay. Thank you.
Yeah, no problem, no problem. Anything else, anybody else? Make sure you guys are clear. If you missed first day or whatever, it doesn't matter. Whatever question you guys have, make sure you ask them. Everybody good, everybody straight, anything. Okay. Anything come up, anything you can think about, feel free to shoot me that email, vtucker@nsu.edu. Outside of that, you guys be safe, watch out for this weather. Take care, have a great weekend, and I will see you on Tuesday.
Susan. All right. Have a great day,
Thanks, you do the same. Take care.
everyone. All right.
All right, take care, take care.